Hello dear students, welcome back. I hope you all are understanding all rearrangement very well. If you have any doubts regarding any rearrangement, please feel free to ask. So today we are going to start Villiger rearrangement. So let us start and see what is Villiger rearrangement. So here I have, you can see here is a ketone and this is a trichloroporacetic acid. So Villiger rearrangement is the rearrangement of aldehyde or ketone in presence of per acid. Okay, so what is happening in the rearrangement? Let us see with this example. Okay, so here you can see we have this ketone and we treat this with our per acid. As like any other acid, the role of this acid is to protonate our oxygen. Okay, and because of protonation oxygen gets 3 bonds and because of that it gets positively charged, and per acid as a side product in the form of its counter ion, we get counter ion of per acid which attack on our carbocation which will form in next step from these species get converted into carbocation, and on that carbocation our counter ion of per acid attacks and we get this kind of species. Here CCl3, here CCl3, this part is of our per acid. Okay, CCl3 carbonyl and oxygen, CCl3 carbonyl and oxygen, and this part I have written it here. Okay, carbon with 2 methyl groups and 1 oxygen, carbon 2 methyl groups and oxygen. So on these species rearrangement reaction takes place because of the oxygen electrons of oxygen repulsion in them. Okay, so this group attached to our carbon migrated towards oxygen, and because of electron repulsion of oxygen bond, this bond gets break and we get again a negatively charged oxygen and a carbocation over here. Okay, this CH3 group migrated towards oxygen with its electron, and because of that what will happen, carbon will get only 3 bonds. Okay, and carbon with 3 bonds means it's electron deficient, and electron deficient species means carbocation. Okay, and this bond shifted its electron towards oxygen, so oxygen will get negative charge. So here you can see carbocation and O minus. So what will happen in next step? O minus will take proton from OH. Okay, this OH acts as a source of proton in next step. Here you can see. Okay, O minus takes proton from OH and that electron shift forms pi bond here, and we get ester as our final product. Okay, so from from ketone, when ketone is treated with per acid, here trichloroporacetic acid, we get ester as our final product. Okay, so let us see what will happen if we treated our aldehyde and per acid. Here we treated ketone with per acid. Let us see what will happen when we treat aldehyde with per acid. Okay, so here is another example in which I have taken aldehyde, and this is metachloroperbenzoic acid. Okay, here you can see the structure of metachloroperbenzoic acid. Here is this is counterpart of metachloroperbenzoic acid. Nothing different, much different. In metachloroperbenzoic acid only proton is there. Okay, this is counterpart of metachloroperbenzoic acid, as this oxygen takes proton. So likewise in next last example, this first step is protonation of our reactant. Okay, oxygen get protonated, and next step carbocation will form, and on that carbocation the counter ion of our per acid attacks on that carbocation. In next step these spaces will form, and as we know that because of electron repulsion this bond should break. Okay, and how this during this bond breaking rearrangement takes place. So here we have two choice, hydrogen and phenyl. So which will migrate? Here I have migrated hydrogen. Why? Anyone knows the answer? If anyone know the answer, yes, we have follow here migratory aptitude. So as we know that hydrogen migrates first, then phenyl migrates, and after that if there is alkyl group, then that alkyl group will migrate. So we will here migrate our hydrogen towards oxygen, and then this bond gets break and we get negative charge over this oxygen, and this oxygen get converted into hydroxy group, and this carbon become electron deficient because this hydrogen takes electron with itself and make bond with this oxygen, and because of that here carbocation will form. So what we get oxygen with negative charge here and one OH. Here you can see this OH and new OH will form here. Okay, and because of that carbocation is formed, and then again that O minus takes proton from OH, and that electron forms a pi bond with carbocation, carbon with carbocation, positive charge, and then what we get, so our final product is this acid. Okay, and this acid we get from our metachloroperbenzoic acid. So this is not our final product. What is our final product is this. Okay, why? Because we have reactant this, we have to react this with per acid. Our reactant is this, and because of that our product is this. This is the byproduct or side product you can say. Okay, so what is our conclusion? From aldehyde we get acid, and in previous example with ketone we get ester. Okay, so remember that from aldehyde in Villiger rearrangement or Villiger oxidation, from aldehyde we get acid, here you can see acid, and from ketone we get ester. Okay, I hope you understand the mechanism. Let us see one more example. Okay, so in this example I have taken this cyclic ketone, you can see here cyclopentadienyl, which I have treated with this perbenzoic acid. So as like last example, first step is protonation of OH, because of that counter ion will form, and in next step carbocation will form, and on that carbocation this counter ion will attack, and after that this spaces will form which you have to migrate the group which is attached to the carbon. Okay, here is in this case we don't have selectivity or we don't have to apply migratory aptitude because both carbons are secondary carbons. Okay, so you can migrate either this or this. I have migrated this because it is near to our oxygen. Okay, so I have, what will happen here, the bond between these two carbons, this carbon and this carbon, get shifted towards oxygen, and because of that this oxygen bond will break. This oxygen get negative charge, and this oxygen forms a new bond with this carbon. I have shown that carbon with another color so that you can understand with which carbon this oxygen forms bonding. Okay, here you can see this oxygen and it forms bond with this carbon, and what happen here, ring expansion is takes place. 5-membered ring is converted into 6-membered ring. Okay, and this oxygen is intact as it is, which act as a source of proton for our counter ion. Okay, and this O minus takes proton, and because of this electrons will which remains on oxygen forms pi bond over here with carbocation, and we get ester. Okay, this is also ester, cyclic but ester. Okay, cyclic ester, lactone, which we called is lactone. From ketone we get ester. Okay, and this is counterpart or side product. Okay, so I hope you understand mechanism. I have given some examples with answer here. I have already given answer so that you can practice mechanism. So please try to solve this by your own first, and then check your answer is correct or not. Okay, here I have used H2SO5 which is kerose acid. Here also, and here TFA. TFA means trifluoroporacetic acid. Okay. Okay, these are some theory parts so that you understand some which acids, pore acids are using, what is migratory aptitude. Okay, so thank you and best of luck.